Now that we've added vectors with the law and cosines, we want to look at doing their x and y components. So first off, let's think of a vector, f, and we break it up into its x and y parts because we know the angle and magnitude. That's just your right angle trig. Cosine goes with adjacent, opposite goes with sine. And so the x part will be f cosine, the y part will be f sine. But that's dependent upon you having that particular angle, right? Which we don't always have. And then in unit vector notation, we define two unit vectors, one along x, I hat, one along j, j hat. And then we can do the vector composition and multiply the x part times I hat, the y part times j hat. And we can think of that as a vector addition problem, right? First go fx, I hat, then go fy, j hat. And we sometimes, if you put the I and j with it, they call that the rectangular vector components as opposed to. And then if we add two vectors and we know their components, like we have a and b here, same picture, first a then b, and then the answer is from tail of a to tip of b. Then you break up each vector to its x and y parts, and then it becomes obvious that the rx is just ax bx, and ry is ay plus by. So our method for doing multiple vectors is going to be break each one into x and y parts, add all their x's, add all their y's, and then go back and do your right angle trig and Pythagoras if you need to find the magnitude and direction of the answer. Now you have to be careful with that inverse tangent. I'm sure you've seen before that if you do inverse tangent, then it's going to give you from plus 90 to minus 90, and you have to check, make sure it's in the right quadrant. If it's wrong, it's always wrong by 180 degrees. So here's an example. I've got two vectors, but I don't have it given with that angle where you would use sine cosine of the angle with respect to the positive x-axis. So I'm going to use what I've got. I'm going to think of breaking f1 up into, I'm just going to use that 30 degrees. And then the y part will be adjacent, so it'll be cosine, and it's the x part that'll be opposite. So the y part will just be 200 cosine 30. Now, when you do that, when you have an angle less than 60 and it's not the standard angle, less than 90 and it's not the standard angle, you have to determine the plus and minus for yourself, because sine and cosine of an angle less than 90 is always plus. So my x part here is going to be opposite, so it's going to be sine 30. And clearly, if I'm going from tail to head, I would go up in y, back in x. So I'm going to force it to be plus and minus. And notice often in the book, you'll get answers. It gives you directions instead of giving you the plus and minus sign. Now, for F2, notice he doesn't give me, this harkens back to the bad old days when, before we had calculators, we could calculate out angles by just punching a button. You had to look it up in the table. So we used a lot of special angles and whatnot so that we could avoid that, and special triangles. And sometimes they still give it that way in books. So he gives you the triangle. He said, this is similar to this triangle. And so what you can do is you could say, okay, find that angle theta, and sine of theta is 5/13 and cosine is 12/13. Or you can just say a little bit differently. The horizontal part of F2 is going to be 12/13, and the vertical part will be 5/13. And so that's what he does. He writes it in terms of similar triangles. So it's going to do, like I said, the x part will be 12/13 times the magnitude. And then the same thing for the other part will be 5/13. Again, do similar triangles. You can write the ratio and it'll work out. And again, you have to decide the direction. So if I'm going from head to tail, I go down in the y plus x. So I'm going to minus y plus x. And if I want to write them as I and j, unit vector notation, then I would do it like that. Okay. Now here's another one where we've got 3, and he's given to us three different ways. We've got F1, which is in the negative x direction. We got 45 degrees here, and then we've got the triangle here. So if we do F1, if we do, let's see, where's he got F1? Well, he didn't write them out separately. He just said we're going to add the parts, so he wrote each one. So he said the 400 is all in the x, so minus 400. The x part of 250, he's using this angle, so he's going to say it's positive cosine. Well, positive because it's pointing in the positive x direction, but it's opposite, so it's sine. So we've got 250 sine. And then this one, do the similar triangles. You're going to use the number that's parallel to the x, so it's going to be 4/5, and it's going to be in the negative direction. So magnitude times 4/5. And then you can add those up. And then in the y direction, nothing for the 400. It's all x. 250 cosine 45, and it's plus. And then the vertical part of that triangle is 3, so you're going to have 3/5 200, and it's plus. So that gives you, add those up, and you get your x and y parts of the resultant vector. And then, of course, do Pythagoras to get the magnitude and do the inverse tangent. Do the inverse tangent. And since they're both, let's see, do the inverse tangent to get the angle. What did we get? We got a minus 383 and a plus 296, which tells us that's got to be, what's that? Minus x plus y. That's over here in this quadrant. So if you do the inverse tangent, then that'll give you a negative number, and you could add 180 or you can add 90 to it. And often in the book, what they'll do is they'll give you a little angle symbol and show you what angle it is. So you have to be a little bit careful. I'm not so sure how the computer's going to answer that. We'll have to work some of those problems out and be careful. Okay. All right. Well, that's adding vectors in 2 dimensions. Hopefully you've done that in calculus and you've done that in physics too. That should be your review. If you have any questions, shoot me an email.